Good afternoon, everybody. Welcome to the Stay Connected webinar series brought to you by SITECH UK and Ireland and also Trimble. My name's Ian Barnes and I'm the head of the business for SITECH UK and Ireland, and frankly, I'm delighted to welcome you all to this webinar. This is specifically around the subject of bringing your data to life with Trimble's SiteVision. SiteVision, for those who don't know, is a relatively new product from Trimble, which is a lightweight handheld augmented reality positioning system, which really helps our customers to visualize and see issues in the field early, to plan and visualize projects and the progress being made, and also importantly in today's world, reduce costs and time. Today I'm joined by Alexandra Andreas, also she likes to be known as Alex. She will be sharing her knowledge about Trimble SiteVision and in a lot of detail. She's one of the experts within the field. After and during the presentation for around 30 minutes, we'll open the floor up to any questions and answers. And if you've got any questions or anything that you want to know more about, please type your questions into the Q&A box and we'll answer those in turn. So now I'm going to hand you over to Alex. Over to you, Alex. Thank you.
Thank you, Anne, for the presentation. Hello, everybody. My name is Alexandra Andres, and I am a sales application engineer working for Trimble. I am based in Raunheim office, and today we will be talking about SiteVision, which, as Jan mentioned, is a new product, which helps you basically project your models into the real world. So the agenda for today is talking about what actually SiteVision is as a product, a slight introduction into the software and hardware. We'll also mention the supported formats, talk about the applications and where to purchase it. As Jan mentioned in the presentation, I will go through my presentation, and then at the end we'll open the Q&A section for answering the questions. So please, if you have any question, just type it in, and at the end I will try to answer. So before we start talking about SiteVision, I think it's important to mention a bit the differences between virtual reality, augmented reality, and mixed reality. We'll start from the right, and we'll say that virtual reality implies a complete immersion experience that shuts out the physical world. For example, the PC games, so you have the goggles on and you're shut out of the physical world, and you're put into that virtual reality, virtual world, playing the game. The augmented reality is basically adds digital elements to a live view, often by using the camera of a smartphone. For sure, many of you already heard about Pokemon Go, or the kids play that. So it's basically having a digital object placed into the real world. And in this category, also, we place SiteVision as a product. And the mixed reality is the merging of the real and virtual worlds to produce new environments. So yeah, you will have a combination of both. Let's say wearing the goggles and being able to adjust the digital models and so on. But today we'll be talking about augmented reality and SiteVision. So what is Trimble SiteVision? It's a high accuracy outdoor visualization of spatial data, integrating GNSS and augmented reality. It's basically, you can see what with your normal eye you couldn't see. It's what in the future the model will look like. So it's delivering complex information in an accurate and easy way to understand. So let's talk a bit about the system components. From a hardware perspective, you'd have the GNSS antenna on top of this bracket. in which also an EDM is integrated, and you'll have also a battery inside that would charge the phone. And of course, you would need a phone added to this bracket. You'd have the application, which is a SiteVision application. It's an augmented reality app. And you would have to run Google AR Core for augmented reality. That is the tool from, like the application from Google for placing like augmented reality objects on your phone. And bring your own device. Basically, the phone, it's not delivered with the kit. It's an Android phone that it can be your own smartphone. And we have a list of supported phones that I will talk about in next, like one of the next slides. So a bit of the software and hardware of SiteVision. If you would purchase a SiteVision kit from your dealer, you would get this bag where you would find an DA1 antenna, which you see on top of the holder, an EDM range finder. So you would basically be able to measure with your EDM some distances and points. And the battery power. You'd have these two batteries that like one battery would last around 2.5 hours. So you have two in the kit. And after they are empty, of course, the phone can run on its own battery. As accessories, you would have the USB connector, a sunshade, which is actually helping also during like a rain, a wrist strap, a pole mount, a phone mount plate, and a phone mount template. This phone mount template would also help you like placing a phone mount plate on in the right spot on your case, so you can actually center that correctly to have the right offset for your camera. And the bring your own device, which is your phone, that is not, as I mentioned, it is not included in the kit. So you'd have to provide yourself the phone. Once you purchase a subscription, a SiteVision subscription, you'd get the application, of course, the Trimble Catalyst Precision, which is an coordinate source for getting the corrections by connecting to VRS Now and or RTX, and it runs on your phone. And the Trimble Connect, which is the cloud platform from Trimble, where you would have to store your projects and download it from there in the application. Of course, this SiteVision is an application, so you'll find it on Google Play. You can even find it now. You just have to purchase a subscription in order to log in. And it will also install the Google Play service for augmented reality, which is well known as AR Core. And another recommendation is that the Android phone must be running at least version 9 of the operation system. But you'll always get an information if your operation system is not up to date. So here we have a list of supported phones and recommended from Trimble. Basically, any of the Android phones that support augmented reality are capable of working with SiteVision, just that they are not tested by Trimble. So if you go on the website, you'll see that there's a longer list of augmented reality supporting devices, but the ones that Trimble has tested and recommends because of the processor or the quality of the camera, which are necessary for placing augmented reality objects, they decided that they saw that the best performance was by Samsung S10 Plus and Samsung S10 5G, which are the recommended ones as, let's say, a higher class for this type of application. But of course, the Samsung S9 Plus, Samsung Note 9, Samsung Note 8, and the additional supported phones. So if you select one of these ones, we recommend, we guarantee a good, like a success in placing the models. And of course, there are certain things that you have to pay attention in selecting the phone. As I mentioned, the quality of the camera, the processor, the RAM, and so the memory of the phone that are very important in working with bigger models and augmented reality. So this would be the main display of the SiteVision once you logged in. And starting from left to right, the upper corner, you'll have an icon which points you the GNSS status. So it will tell you the accuracy that you have, horizontal and vertical, and the number of satellites that you are now tracking. So if you would click on that icon, you'd get more information about which type of satellites you are tracking and the accuracy that you have. So just click on it and a window will open where you can see the list of the satellites that are tracked. The second button is the orientation button. So when it's green, it means the model is orientated, which means that after placing the model, the system will ask you to walk in a straight line for a certain meters, let's say 10 meters, depending on the settings that you have, in order to align the model. So it's used for orientation, considering that we are working with GNSS. So once you are aligned, of course, the model will not be floating anymore, and it will be nicely set on the construction site. Then the third button is the distance slider. So let's say if you are working with long models like streets, roads, bridges, and at the end of the model being so far, you see that the model looks like it's floating. You can work with this slider in order to see only, let's say, the first 200 meters of the model. And once you move along, you can always increase the distance. The fourth button, and I consider it the most used one and important, is the menu button, of course, where you can load the model or set up your GNSS connections or your settings. So once you click that menu button, you can go into different setups. Number 5 is the cross-section slider. So the way you use the distance slider, you can also just see cross-sections of your model. It's used in the same way. Number 6 is the application button. So this button basically opens up a certain, like a list of measure possibilities. So we'll talk about it a bit later, but that's the button that you need to select either measuring a point or a distance or a slope or the to-do button, which is taking a picture. And number 7 is the transparency slider. So you can work with the transparency of the model if you'd like to see better the reality in the background, as you see in this picture, seeing the tracks of the dozer, for example, or you can make it solid, so you block basically the image in the background. Number 8 is the button to change between 2D and 3D views. So this is the 3D view, but you can also change it to the 2D view in order to see planimetrically where you are standing on your model, for example. Number 9, the pit view option. It's a tool that helps you visualize underground models, underground utilities. And I have a different slide to talk about more about the bid view option, but it's very useful for underground utilities. And number 10 is the layer button, where you can switch on and off different layers of your model, depending on what you want to see on the screen. So we've already saw the application button. This one is opening a list of other buttons once you click on it. The first one to the left is the to-do button, which means you can capture an image, which surprises both the reality, so the street behind the model and the model, and you can save it on with a few informations on your on Trimble Connect. Like this picture is georeference and is saved in the same folder associated to the project in Trimble Connect. The second button is the measure a point button. So you have the possibility to measure points, either directly into the model or on the ground, the real surface. The third is the measure cut and fill button. So you can measure either cut or fill between the model and the real ground. And the fourth button is measure grade and distance, which will give you the distance between 2 points with a slope. There are 3 ways of placing a model. The first one is, which is mostly for indoors, is the manual placement. So let's say indoors where you don't have a GNSS connection, where it's not possible, you can place the model manually by just using the AR Core application from Google and the camera of the phone. It will place the model by using the recognizing the differences between shades, colors, surfaces in your room. The second way of placing a model is the measured one. So outside, once you connect it to your correction source, let's say VRS now, and you get correction data, you'd be able to place the model by measuring 2 points. So the first point would be for positioning the model, and the second one is for orientation. Once you do this, the model will be fixed on these 2 points position. And if you, let's say, switch it off and you come the next day and turn it on, the model will still be placed in the same spot. So you don't have to repeat this process unless you see that the way you placed it, it's wrong. And the third and the most recommended one is the automatic placement, which means that if you load the model with a calibration file, and these are the 3 formats for the calibration file, JXL, CAL, and DC, which are Trimble formats. If you have the calibration file and the model with the right coordinate system, you save them both in the same project on Trimble Connect, and the application will place automatically the model using the information out of the calibration file. So you basically just have to download the model and let the application work for you. So the measurement modes, there are 3 possibilities, and you see them on the screen here. So first is the GNSS measure mode, which means that you would have to set the kit on a pole, like a surveying instrument, so on a range pole, and put that range pole on a point and measure vertically to the ground the point or the distance, for example. So that's the GNSS measure mode. So it's measured vertically the tip of the pole, let's say, the position of the tip of the pole. And a second way would be the EDM one here, which the EDM will connect with your phone through Bluetooth. So you'd have to pair it first per the device. And then you will be able to measure points or cut fill or distances by using the EDM. And the third way of measuring is the AR method, which is just using the camera of the phone, and you'd be measuring a point in the model, so in the digital model, not in the real world. As mentioned before, there are three functions, measurement functions: points, cut, fill, grade, and distance as a line. Once you measure the point, you see that a window is popped up with point details where you can type in the name, the code, and you would get a slope distance, horizontal distance, and of course the coordinates, showing you also the coordinate system that the model is working with. And there are two measurements that can be done, either between real world to the model, which let's say would be a cut fill between the real world and the model, and real world to real world. So let's say it would be using the EDM measurement. So as you see in the first picture, that would be, let's say, an EDM measurement. I don't need to see my model. I just want to record the point on the pedestrian area, so on that surface. And there would be another way of measuring this also with AR, which I mentioned before, that using AR will only save the point, record the point in the model, so digitally, let's say. All of these measurements are stored in a CSV file, and the CSV file will be synchronized with Trimble Connect. So once you first record the point, or let's say a picture, you'll see that this icon here will show up, which allows you to type in the name of the file and then synchronize it with Trimble Connect. The data will be stored in an Excel sheet, like the one that you see below, which gives you all the information you need if it's measured. Let's say the point was measured with EDM or GNSS. If like the coordinates, the pole height, if I used one. Yeah, so local coordinates like grid and grade coordinates. So you can use this CSV file afterwards to import it in a different CAD software if you want, and you can work with the points or the information in a different software. So in terms of accuracy, there are three types that we have to take into account. So first would be the GNSS accuracy, which is the one from the Catalyst software and the DA1 antenna. So that's horizontal 1 centimeters, vertical 2 centimeters in like the perfect conditions. So not in the woods, for example, in good VRS coverage areas, or RTK fixed. So that would be the first accuracy that would be applied to your model. The second would be the EDM one. So the EDM itself has an accuracy of a few millimeters, but it's always combined with the GNSS and the alignment accuracy. So first of all, the model has to be correctly placed. Second, it has to be orientated. Third, to have a good GNSS accuracy. So then I would get a good 2.5 centimeters accuracy of my measurement with EDM. The practical range is between 1 meter and 25 meters. So it's recommended that you don't measure a point farther away than the distance that you walked for aligning the model. So let's say if I walked 10 meters to align the model, for the best accuracy, it's recommended to measure a point between 1 and 10 meters. And the third is the AR accuracy. So when you measure a point with AR, in the AR mode, and that's only depends on the mobile device and the AR core calibration. That has to do with the camera, the offset of the camera, and so on, not exactly with GNSS or ETM. So it depends on the phone. With the new version of SiteVision 1.10, the operator has the possibility to work with SiteVision and models also in environments where it doesn't have an internet connection. And how does that work? First, you would have to be connected to the internet, let's say in the office, and you would download, so you'd log in. For that, you need internet. You'll download on your device, so not selecting Trimble Connect, but here on device, you would load the model, which will be storing the model on your phone. And once you've done that, you can go outside on the site. You no longer have to be connected to the internet. You can just select the model out of the folder on your device, and the placement will be made by using RTX. So you'll be connected to RTX correction source. And of course, that is with the model, the placement will not be as accurate as using VRS now, because that's a different accuracy when using RTX. Another, let's say, small disadvantage of not being connected to internet is the fact that you can't have a direct sync with the recorded points. So the CSV file will still be, let's say, stored on your device, but you have to remember that once you are back to the office and you connected to your phone to the internet, to just synchronize one time this CSV file with Trimble Connect. If you remember, like when I presented the display menu, there was this bit view tool. What does this tool do, or how does it help? For underground utilities, it's basically placing this bit view, this hole, like digital hole, for suggesting or simulating the underground utilities without having to dig for it. So you see the rest of the lines, they look like they are 2D on the ground, but where I do place this pit view tool, I basically create a hole where I can see my utilities better to understand that they are actually 3D. And if the model is saved with attributes, let's say like an IFC model or coming from a GIS software, then you would also be able to just click on the, let's say, the pipe or the model, and it will give you the attributes like in the picture on the right. So the diameter, the color, all the information about that pipe. Now let's just talk a little bit about the supported data formats. So for placing it automatically, of course, you need the calibration files, which are JXL, DC, and CAL formats coming from Trimble Business Center or SiteWorks or Trimble Access. And the supported types are the VCL/TRB formats. These are Trimble formats. And a TTM for surfaces, a SketchUp model coming out of the SketchUp software. All these three are Trimble software formats. The VCL is basically like a Trimble LandXML. So you can have surfaces and lines and points in one project. Then it also can be imported a LED XML format or an IFC B model, or a shapefile which is coming from GIS, or a DWG-DXF from either from SiteWorks or Autodesk. So these are the supported formats. Of course, there are different ways of preparing the data according to the format that you have and the information there. You can see on the right column the recommended use cases depending on the format that you have. And there are also a set of YouTube videos that can help you to prepare your data for correctly visualizing into Trimble Sitevision. And now I will present you a set of applications based on the customers that we already have. So you can see that from the traffic signals to the roads, before actually building anything, you can visualize it first and check if it's actually the right one before investing some money in starting building it and realizing afterwards that it's something that it doesn't actually work out. So that's a really good tool to see that before. Also, future constructions, buildings. It's good for inspections and underground utilities. Also, I'm sure some of you are familiar that before a construction company starts rehabilitating a street and finding the underground utilities, they will wait for a surveyor to come and stake out, let's say, and mark on the street, on the asphalt, where the lines or where the pipes normally come, so they know where to dig for it. With SiteVision, you can actually visualize it before, so there's no need on marking it anymore. You can also see the property boundaries or a construction site boundaries pretty easy without having to stake out boundaries. Also, before building anything, you can also understand the visual impact. Do I have to cut down some trees, for example, before I start building anything? Or is there something in the way? It's good also for reviewing landscape plans, how it in the future would look like. And of course, it's a really good tool for the ones who don't understand, can't imagine 3D, let's say a 2D paper plan. Yeah, of course, viewing the underground utilities and using this pit view tool. And showing cut fill maps on the construction site and managing earthworks. And I have a short video about the applications for construction. So this is how it would look like if you would load a model into SiteVision. You can see the functionality of the cross-section bar and how it looks like when you're measuring cut fills. It will basically draw this, let's say, solid pipes like vertically, showing the cut, for example. And this is the to-do function, recording, capturing a picture and sending it to the office. As I mentioned, it's a georeference picture. This is synchronizing my CSV data file with the measurements. And here is for inspections, for example, playing a bit with the transparency of the model, understanding how it looks like in the real world and how it is digitally, how it's planned, and how it will be looking. Another example of a future street and a cut field measurement between the model and the original ground. So for any interest, if you would like to purchase the SiteVision kit, you can either contact your local SITECH dealer or just check it online under the SITECH UK and Ireland website, and you will have more information there as well.